Assalamualaikum warahmatullahi wabarakatuh. My name is Hakimi Biman Safari, and we are from group number 5. And our project is squamous cell carcinoma skin disease image classification using RNNs versus RNN plus SVM. So let's get started with the introduction first. So as we all know that skin cancer is a growing global health concern, which millions of new cases are reported annually. So making an early detection is essential. Squamous cell carcinoma, or SCC, is one of the deadliest forms of skin cancer. It is an aggressive type of skin cancer that requires timely and accurate classification for better treatment. So the previous way, or the traditional way, to diagnose this skin cancer are very limited. So the dermatologists rely on histopathology, which is very subjective, time consuming, and prone to errors. So, with the involvement of AI that transforming the medical imaging, mostly we will using deep learning models, particularly CNN or convolutional neural network uh, that will that will use to automate the diagnosis and improve accuracy. But since our project is focusedly and mainly is for RNN, recurrent neural network. We will try our best to get the best accuracy, the best result to ensure that our model could detect or classify the SEC. I think that's all from me for this part. Thank you. Next presenter.
Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aziz bin Muhammad Aris. So we'll give a presentation about the first one is problem statement. So basically there is 4 problem statements for our project, which is the first one is challenges in SCC classification. Second one, CNNs are widely used but have limitation. Next one is RNN can analyze temporal relationship. And the last one is hybrid model, which is RAN plus SVM are a promising solution. So we will go through the first problem statement, which is challenge in SCC classification. As we know, in differentiating SCC from other skin lesions is difficult due to their visual similarities and variations in image quality. So the next one is CNNs are widely used but have limitation. Widely known, CNNs have a limitation. So this is one of the big problem for us, because they focus only on spatial features and cannot capture sequential change in histopathology image. The next one is RNNs can analyze temporal relationship, which is they can identify sequential pattern in skin lesion images but struggle with small data set and features extraction, which is it is make us hard to identify others than sequential patterns for our image. And the last one is hybrid models, which is RN plus SVM are a promising solution. So combining RNN for pattern recognition with support vector machine SVM for classification can improve diagnostic performance. So the next part is the objective for our research, which is we have 3 main objectives. The first one is to classify SCC image using recurrent neural network. So basically, we are evaluate how well RNN perform on their own in identifying SCC from medical image. So as we know, our topic is about the skin. So it is related to medical industry, and we try the best to make it work for medical image. The next one is enhanced classification by integrating SVM, which is hybriding RNN with SVM is expected to improve classification accuracy and overcome individual model limitation. And the last one is compare performance between standalone RNN and RNN plus SVM, which is we need to know the comparison, which is which one better, RNN or RNN with SVM, which is there's a few part that that make as our focus, which is assesses accuracy, precision recall, and other metrics to determine which approach is more effective. So basically, this is our main objective, to make sure that our research can be run smoothly. So
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adis Ibrahim Naim, and I will present about related work to our project. So for the first one is CNNs have dominated medical image classification, which is they are excellent for feature extraction but lack the ability to analyze temporal patterns. The second one is RNNs are useful for sequential data processing. They are typically used in time series analysis and natural language processing, but their application in medical imaging is less explored. The last one is hybrid models show potential. Studies suggest that combining different AI techniques leads to improved performance, especially for complex datasets like SCC images.
Alright. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikon Hakimi bin Muhammad Aizam, and for this part I will continue with presenting methodology of data collection. So in here you can see that there are three types that we have split, which is first is the dataset source. So for the dataset, we have obtained the images from Kaggle, a publicly available repository of high resolution skin lesion images. We use these images to do our training and testing, and that's all of the images that we have gained from there. Next is the pre-processing steps. There are 4 types of pre-processing steps that we have used, which is first grayscale conversion, where the RGB images are converted to grayscale if necessary to simplify the data and focus on intensity patterns. Second is the image resizing, where we resize all the images to a fixed dimension of 70 times 50 pixels to ensure consistency across the dataset. Third is the contrast enhancement, where we apply adaptive histogram equalization to improve the visibility of features in the images. And lastly is the normalization, where the pixel values are scaled to a range of 0 to 1 by dividing by 255, facilitating by better performance during training. And lastly is the data split for training and testing, where we split the images to 800 images for training and 200 for testing. Next is the model development. So for RNN, which is recurrent neural network, it is designed to process sequential data. It also helps it analyze changes in skin lesion structures over time. Next, support vector machines, SVMs. It is effective in classification, especially for small data sets. It also helps refine predictions made by RNNs. So after RNN and SVM, there is also a hybrid RNN plus SVM model, where RNN extracts important sequential features, and then SVM classifies these features into SCC or non-SCC, which is squamous cell cancer or non-squamous cell cancer, and then improves classification accuracy by combining strands of both methods. And then by hybrid RNN and SVM model, we then implement it at MATLAB implementation, where we used it for model training, testing, and evaluation. And then image process, the toolbox is utilized for pre-processing steps, and then neural network and SVM classifiers are implemented using built-in MATLAB functions.
Assalamualaikum warahmatullahi wabarakatuh. My name is Iman Hafiz from Visual ID, and right now I will explain the results of our experiment, which is the model performance. So the first one is the comparison of accuracy. So RNN alone has model performance, but RNN and SVM improves classification accuracy. The second is the precision and recall values. So the hybrid method, which is the RNN and SVM, reduces false positives and negatives, and it ensures better detection of SAC cases. And the last one is the tables graph of results of our experiment. The first one is we have the accuracy comparison and the table of confusion matrix showing correct and incorrect classifications. So next one is the discussion. The first one is RNN and SVM improve accuracy because it captures both spatial and temporal features effectively. The second one is better SSC detection. It reduces false positives and improves sensitivity. The third one is MATLAB efficiency in implementation. So we're using MATLAB in this experiment, and it simplifies image processing and model training and allows easy integration of neural networks and SVM classification. The last one is the challenges and limitations. So the model performance depends on dataset quality and size, and also real-world validation is needed to ensure effectiveness in the clinical settings, the real clinical settings. So next one is the conclusion of our experiment. So the key findings of our experiment is the hybrid model, which is the RNN and SVM, outperforms standalone RNN in SCC classification. The second one is AI-based models can enhance the accuracy and efficiency of skin cancer detection. And RNN works best when we decrease the size of image and change it to grayscale. So next one is the MATLAB contribution to the experiment. The MATLAB software itself provided a flexible environment for model training and testing, and it is effective for handling image preprocessing and deep learning models. So the last one is the potential applications. So AI powered is potentially can can be a diagnostic tools to assist dermatologists, and it is faster and more reliable SSC classification for early intervention. So we move on to the code explanation. So I will explain the first process of our codings. So the first one is define input and output directories. So sorry. So we declare the input directory, which is the pre-processed image. This is where we store the original image before we process it later. And the second one is we name the output directory, which is the output dir. This is where we save the processed image after we doing all the process in the codings. Next one is get list of all image files. So this uses it to search for all .jpg files in input directory, which is the original image stored, including the subfolders. So the next one is to check if images exist. So if no image are found, it throws an error, no images found in the folder. And if the image is found, it will display found image in the input directory. So the second process is define output image size. So This specifies the target size of the processed image. And next is to process each image. So for I equals to I num image, it iterate through each image in the directory. And read image. Read image. This code construct the full file path for the image, reads the image into MATLAB, and next one is convert to grayscale if needed. So if we convert to grayscale first, it will be we will be getting higher accuracy for our image, so it will be easier to detect the skin cancer, the skin sickness. So next, we apply histogram to enhance the contrast and also apply medium filtering to reduce noise. And we do resize image and we do normalize pixel values to range 0 and 1. And then we get the relative subfolder path. So it extracts the subfolder structure of the original image and remove any leading slashes. So the last process of this process.MATLAB file is to create the corresponding output subfolder. So this code ensure the process image is saved in the same subfolder structure within output directory, which is the folder that store the process image. And then we save the process image. We save the process image in the correct subfolder. And next is to convert to UINT8 for saving. So this and we save the file. We save the file in the correct directory, which is the input directory, which is the output file directory, and it will display that the image is processed and saved. And lastly, all images, it will display all images processed and saved in correct subfolders. So that's all for me. Thank you.
Moving on, now I will be explaining the code for rnntrain.m. So as you can see, there are multiple steps needed where we will continue in rnntrain.m. So for the first step, we will load the image dataset. In this case, the input directory stored from processed images, which is the dataset directory or the dataset folder containing all of the images inside the folder. And then after we done training and stuff, it will be then saved into another output directory, which is the RNN model, where the model file will be stored inside there. And then for the loading of images and labels, it is stored inside the imds variable, where we receive the folder of processed images and use the function of image data store to which then imds will store the code inside this variable. And then we use the split dataset into 80% training and 20% training. It is randomized. The images will be randomized, and 80% will go into IMDS train and 20% will go to IMDS test. Now we onwards to step 2, which is to pre-process the images. So we store the variable of image size into 70 height times 50 width, and the imds train.files will the function will count the total of files contained inside the imds train content, into num train and 20% go to num test. Next is the x train and x test. Using the function of cell, it will go to the function into the variable. Now we go to the training data preprocessing. So firstly, it will scan all of the images inside the file of imds train, and it will convert to grayscale if needed. So in the cases that the images are already grayscale, there are no need to go to this step. It will then directly go to the function of image resize, where it will resize the image to 7050, where we gain it from the variable of image size based on step 2. The images will also goes to a transformation of contrast enhancement using adaptive histogram equalization, and then stores it again inside the image variable, img variable. And lastly, the images will go to a function where it will flatten and normalize the images. The next step is testing data processing, where it will go through a similar situation from training data pre-processing as well. Next, we will convert the labels to categorical, where the IMDS train labels and IMDS test labels will change into a category. We change it based on the categories, which is for squamous and non-squamous. So now, step 3, it will then go to define the RNN model, where it will the function is used to ensure correct class count, and then contains there are also layers and options. In this case, the layers are sequence input layer, LSTM layer, where we set it into 256 units, fully connected layer 50, value layer, fully connected layer, and the parameter stored are num classes, softmax layer, classification layer. For the training options, we have set it as Adam and test it with 50 epochs, mini batch size 16, initial learn rate 0.001, and then it will also shuffle for every epoch of the every images, and then the validation data of the X test and Y test, validation frequency set it to 10, verbose 2, plots, training progress. To continue, we will onward for step 4, which is to train the RNN model. So we will use the function train network and receive the parameter for X train, Y train layers and option, which was received from step 2 and step 3. So from this function, it will then be stored inside the variable of net RNN and then display RNN training complete. After going to the phase of training RNN model and it is finished, it will then save the model. Firstly, if the output directory does not exist, it will make the directory. If there is already one, it will then continue with the function to save a file name called scc_rnn model.mat, where it will store the netrnn function into the file folder, and then continue to step 5. So step 5 will evaluate the performance. So it will predict and classify the netrnn and X test where we have done the training of RNN model inside NetRNN, and then it will calculate the accuracy, which is the sum of y prediction equals to y test divided by num of y test times 100, and then you will print RNN model accuracy with a pointer of 2 getting the variable of accuracy, and then it will also generate a confusion matrix in a figure. So it will generate the confusion chart as well as the title, column summary, and row summary. And lastly, step 6, it will display the final results saying the model performance have been evaluated. Check confusion matrix for detailed results. As you can see in the picture, there is a file generated which is scc_rnn_model, which is stored inside the folder of RNN model. For your information, for the rnn train.m file, after we run all of this code, the result that we have tested was receiving about 55%, which was the highest that we ever received. Alright, so that is all from me. Thank you.
Okay, for the coding part is rnn_svm.m. So the first step, we load the image dataset from process images folder, and then after done the process, we will insert the image or dataset to RNN models folder, and then we load image and labels, and we split dataset into 50% training and 20% testing. So because of that, we use 0.8 to split it, and then we move to the step 2, which is pre-process image. First step is we resize. We set the image size to 70 times 50, which is height times width, and then we use numTrade and numTest. And then we training data pre-processing. So for the first step, we convert the RGB images to grayscale images if needed in this part, and then if the image is already in grayscale, we will moving on to resize the image by using this image size, which is 70 and 50, and then we enhance the contrast by using histogram equalization, and then we flatten and normalize it. For testing data pre-processing, it's the same like training data pre-processing. So the first step, we convert the RGB image to grayscale image if needed. So if no need, we just continue to resize the image and do enhancement by using histogram equalization. And lastly, we convert labels to categorical. And then for step 3 is define RNN model. We use num classes equals to numl, and this is the layer. To use it, we use sequence input layer, LSTM layer, LSTM with 128 units, fully connected layer, 64 relu layer, fully connected layer, softmax layer, and classification layer. And this part is training options. We use options, training options, which is Adam, which is adaptive moment estimation method. And then we set the max approach to 50 and mini batch size to 16, initialize learn rate 0.001, and we shuffle every approach and so on. Next, we moving on to step 4, which is train RNN model. We set the net RNN equals to train network, and this is there are 4 parameters, which is X train, Y train, layers, and options. Yeah, and then for the last step, which is step 5, we extract features from RNN, and if the image is strain, we use feature strain, and if the image is testing, we use the features test.
Assalamualaikum warahmatullahi wabarakatuh. Next, I will walk you guys through the process of training and evaluating a classification model that combines a recurrent neural network (RNN) for feature extraction and a support vector machine (SVM) for classification. Let's break it step by step. So I will continue the step that Haris already explained, which is I will continue to step 6, which is step 6 is to train SVM on RNN features. First, we train the SVM classifier using the features extracted from RNN. We display a message to indicate that training has started. So the example of the coding for this is DISP, training SVM classifier. Next, we use the fit CSC566 function to train the SVM model. The features train variable right there contains the features representation from the RNN, and y train consists of the corresponding labels, while fit CSCOC is a function that train a multi-class SVM using error correcting output code ECOC. So let's go to the step number 7, which is to evaluate performance. So first of all, we make a prediction using the code ypred equal to predict SVM model features test. Right here, we use the train SVM model to classify the test data. The next one, calculate accuracy, which is we compare the predicted labels with the actual label to determine classification accuracy. And the last one is visualize with the confusion matrix, which is the last part of the code, which is this section help us analyze classification performance and error distribution. Next, next, let's go through step number 8, which is the step number 8 is to count correctly classified image, which is calculate correct and incorrect classification. It's the first part of the coding, which is the correct classify, misclassify, and the next part is to display classification result, and the last part is identity and show misclassified example. For the last part, if there are misclassified image, we will display up to 5 examples for analysis. And the last step, which is step number 9, to save RNN plus SVM model. This is to ensure the output directly exists. And the second part of the code is to save the train model, which is the train model is stored in a .mat file for future use. So the conclusion for Haris part and my part is that we successfully trained a SVM classifier using features extracted from a RNN. We evaluated the model's performance using accuracy and confusion matrix. And the last one is we analyze misclassified cases and save the train model for future prediction. That's all from me. Thank you.
Okay, hi, it's me again. So for the GUI part, I will explain a bit about it. So our GUI name is app1, as you can see here. So this is the properties that correspond to the app component, which is the UI. So we have several things here, which is buttons, RN, upload, some UI access, and label. Also we have tab here, and this part is the properties that will hold the RN model, RN plus SVM model, and the upload image. So um, it is net, SVM model, and image data. Then here is the upload image button push. So whenever I push this button, it will load the RN model and RN SVM model if not already loaded. So it will check the model for RNN here, add the RN model, which is the name is SEC underscore RN underscore model dot man. So it will using net here, app.net, as you can see here, and also for the load to load RN SVM model, we are at the models RN models here. So the file is sec underscore rn underscore svm underscore model dot man. So we will using svm model here, as you can see dot svm model. We read it. So of course when the model has loaded, it will display this one, rn loaded. Else it will display fail, as you can see here. So the next part is still under the upload image button. So after the model has been uploaded, um, you will open file dialog to upload an image, a random image. So as you can see here, several type of images. Then if I did not select any images, it will display no file selected. And then uh, after I put the image, yeah, it will read and display the image. So you will put the image under this y-axis original image. Else, yeah, it will display fail to read the image. Okay, next we continue with the next function, which is rn button push. So whenever after I upload the image, I can push either rn button or rn svm button. So I wanted to tell you that both button work similar, same, but the only difference is the properties that they are using, which is net for for to store the train RN model, and SVM model to store the RN plus SVM model. Uh, other thing is the same. So as you can see here, after if I push the RN button, for example here, and if it empty, meaning that there's no image, so it will display please upload an image first. Then if the image is there, then it will go to step 1 to pre-process the image. So we will convert the image to grayscale and resize it, and then I will apply the contrast, and we will flatten and normalize it. And the step 2 is to classify image using RNN. So before this, we already load the RN model. So right now, um, the model will classify the image. So if it successfully classified, it will display this RN classification result, meaning that it already done. Else it will display error. Uh, how to? Otherwise, it will display error. So oh, sorry. Okay, otherwise it will display error. Then in the right part of the UI, you will see the process image, which is at the UI axis underscore 2. So if the image that I put is a squamous, then yeah, you will also display squamous image, malignant and cancerous. Otherwise, you will display non-squamous and benign, which is non-cancerous. So here is the RN SVM button. As I mentioned before, the flow is the same. Uh, Change to grayscale, convert to grayscale, resize it, apply contrast, flatten and normalize it. And then same also with this one. We classify using the RNN. If I put squamous, yeah, it will display squamous. Depending on the image that has been trained. So um, as my friend mentioned earlier in the previous one, um, our accuracy is not that high. So maybe some images it could not read it because we are using RNN. So for example, sometimes when I choose a squamous image, it will read as non-squamous image, and vice versa, because the accuracy that we try to get, um, the highest one is 60 around that. So it is almost impossible um, to get a lot of the images to be true or correct. So that's why we already do this test and uh, evaluation in the report, so you can see there. Okay, so everything is the same here, and then yeah, okay, so this one is the UI of our UI. So um, so actually if okay, for this example, um, this is actually through a non-squamous image. So when I upload it and I using RNSVM button here, so it could read the image. So that's clear. So and this one is the grayscale image, and which is when I press this button, it will go through this step first, and then it will appear the finalized image here. Then the output is here. As you can see, the result non-squamous, benign, non-cancerous. So it is true here. The image is actually a non-squamous image. So I think that's all for the slide part. So we can proceed with the real demonstration. Thank you.